Hi students, let's look at this question here, which was taken from the year 2017, paper 1, question 10 of the H2 math paper. Let's see how we can do this proficiently. So you're given that the electrical engineers are installing electricity cables on the building. Point X, Y, Z are defined relative to the main switch. So main switch is 0, 0, 0. So we'll just let it be 0 here. And we have cables are laid in straight lines and the width of the cables can be neglected. And the existing cable C starts at the main switch and goes in this direction here. So I'm going to draw this line here. So this line, what we can tell is actually it goes in this direction where this is 3, 1 minus 2. Okay. And existing cable C, so this is actually the line C lah. So you just let this be C. I'll just label it as line C, it's easier. Okay, so that I understand that it's a line. So a new cable is installed and passes through P and Q. Okay, great. So this is P and Q. I'm not sure whether P and Q will pass through the main switch. Let's just I don't think it is, right? Okay, great. So it's not. I think so. So we just assume that it's not first. So this is P, and this is Q. Okay, I do not know where is P and Q as well. So, but I'm just gonna draw it out. So this is 5, 7A. Find the value of A for which C and the new cable will meet. Okay, great. So that's pretty okay. Now, in other words, line C, we can simply put as R equals to 0, 0, 0 plus lambda 3, 1 minus 2, where lambda is real value. Okay. Then you have got line PQ. We could use 1, 2 minus 1 plus mu. And this should be PQ. So PQ will be 5 minus 1, which is actually 4. 7 minus 2, which is 5. A plus 1. And this would be mu real value. For the first part, lines will meet. Meaning there will be a unique solution, right? So LC equals to LPQ. In this case here, we have 0, 0, 0, which is redundant. Actually, I could just write this as lambda 3 minus 2 equals to 1, 2 minus 1 plus mu 4, 5A plus 1. Okay. So then we get 3 lambda equals to 1 plus 4 mu. After which lambda equals to 2 plus 5 mu. And minus 2 lambda equals to minus 1 plus mu A plus 1. So from these two expressions here, we can use GC and solve it. I'm just going to use this, rearrange this. Minus 4 mu equals to 1 and lambda minus 5 mu equals to 2 from GC. Okay, I could simply write it as just in calculator. So new equation, simultaneous equation 2 will be 3 minus 4 and 1, 1 minus 5 and 2. So this will be lambda equals to minus 3 over 11 and negative 5 over 11. Okay. So you're told to find A. So minus 2. This will be minus 3 over 11 equals to minus 1 minus 5 over 11. 5 over 11 A plus 1. Okay. So same thing. Just use calculator to calculate this part here. What I'll get is actually 6 over 11 plus 1. And multiply with negative 11 over 5 and minus 1. Minus 22 over 5. Okay, so A minus 22/5. Okay, so this is how you do this part here proficiently. I think it's pretty okay. So let's look at the subsequent part. To ensure that the cables do not meet, so you don't want them to meet, you want them to skew, right? So when it's meeting, is A is minus 22/5. But in order for it to be not meeting, means you can use any other A value. So A equals to -3 is being used. The engineer wish to connect each of the point P and Q to a point R and C. So I think I'm just going to draw a new diagram and see how this would work. So we have PQ, LC. Okay, great. So this is LC, PQ. Maybe I'll just draw it above here, skew line. So this is O, and this is C. C would be I'm not sure what C. Set it LC. R equals to lambda 3 1 minus 2, and this is P, which is actually 1 2 minus 1, Q, which is actually just 5 7 -3, 5 7 -3. Okay. Then the engineer wish to reduce the length of the cable required and believe in order to do this that the angle PQR should be 90. Show that this is not possible. So we wish to connect a point PQ to R on C. So there's an R here. I'm not sure what's my R. So they say that this could be 90. We do not know whether this is 90 or not, but you could show. Okay, so anyway, R is on OC, right? Then we're using -3, so this is what we're gonna do. We're gonna show that show is not possible. Need to show that. So PQ RP RQ is 90. It's not 90 degrees. Okay. So in other words, we need to show that this cannot be 90. Okay, so this diagram obviously is wrong, but we want to show that this could not be 90. In other words, we need to show that PR dot RQ QR cannot be 0. Okay, that's one way to do it. Yeah, you can just show that it's not equal to 0, the dot product not equal to 0. Can't be 0 in another way. Okay, so let's just see. So for some lambda equals a real value, I do not know what's the coordinate of OR. So I'm just going to use OR is the line equation lambda 3 1 minus 2, because R is on line LC, meaning to say it satisfies the line equation. Then now I've got PR, so I'm going to find PR first. PR will just be lambda 3 1 minus 2 minus 1 2 minus 1, which is actually 3 lambda minus 1 lambda minus 2 lambda plus 1. All right. Then after which we have got QR. So QR will be R minus Q, which is actually, this is lambda. So this will just be 3 1 minus 2. But it doesn't matter which one you do, right? It could be RP dot with QR, it doesn't matter. So R, as long as you need to show that it can't be 0, because if it's 0, then yeah, then it will be 90 degrees. So lambda minus 5 minus 7 and minus 2 lambda plus 3. Okay, so this is how we do it. So what we can do is actually just find PR dot with QR, which is equals to 3 lambda minus 1 lambda minus 2 lambda plus 1 dot with 3 lambda minus 5 lambda minus 7 minus 2 lambda plus 3. Okay, before I proceed, let me check my working. So it's okay. So this part here, I'm just going to proceed to dot them. So 9 lambda square minus 15 minus 3, so minus 18 lambda plus 5 add with lambda square minus 9 lambda plus 14 plus 4 lambda square minus 6 minus 2, so it's negative 8 lambda plus 3. So add all of them together. Basically I just dot them, right? So dot this, we'll get this, and this will be 14 lambda square minus 18. Okay, brain is too think too much. Plus 9 plus 8 is 35 lambda plus 19, so it's 22 plus 3. Okay, so we're going to complete the square, or we could use discriminant, it's easier. So discriminant, I'll just complete the square, I think it's easier also. So complete the square by taking this out. So 14 35 over 28 square plus 22. Alright, so this would be 14 multiplied with 35 over square negative 1 over 8. This is more than 0. Okay, so you just complete the square and you realize that this is actually more than 0. So since P r dot qr is more than 0, hence it's not possible. PRQ cannot be 90 degrees. Okay, so that's not possible. So this is how you do this question here proficiently. So let's look at the part 3. Part 3, the engineers discover that the ground between P and R is too difficult to drill through, and now decides to make the length of PR, so meaning to say this PR to be as short as possible. In other words, you want to move your R around, right, to the shortest. In other words, you're looking at R to be shortest over here. Because R could be moved, but P can't be moved, right? So this has to be short. So find the coordinate of R in this case and the exact minimum length. Okay, that's pretty okay. I think just find the foot of perpendicular. You could use mod PR and dy dx it, but I prefer to use a dot product. Not sure which one is faster, but I'm just going to use a dot product. So you could just take so basically part 3 is finding foot of perpendicular P to OC, line C lah. Okay, so we have P here. So we have PR, right? We found PR just now. PR is 3 lambda minus 1. So PR is 3 lambda minus 1, lambda minus 2, and minus 2 lambda plus 1. Negative 2 lambda plus 1. Negative 2 lambda plus 1. Okay, so negative 2 lambda plus 1. Okay, great. So once this is done, what we need is it to be 90 degrees. So PR dot with 3, 1, negative 2 will be 0. Because it's 90 degrees. Correct? I think the dot product should be quite okay. So this is 3 lambda minus 1 lambda minus 2 minus 2 lambda plus 1 dot with 3 1 minus 2 equals to 0. So it's 9 lambda minus 3 plus lambda minus 2 plus 4 lambda minus 2 equals 0. So lambda would be oh my goodness, 14 lambda 2 7. So lambda is equal to half. Okay, so very quickly you can go to half. So in other words, OR, position of OR, coordinates of OR will be lambda. OR just lambda half 3 1 negative 2. Okay, coordinates of R will just be 3 over 2 comma 1 over 2 minus 1. Great. Then you want the length, the minimum length, exact minimum length. I think should be quite fast. Exact minimum length will just be P mod PR. Okay, so this case here, I'm just going to substitute into this part here. 2, well, that is a lot of weird. So PR will just be 3 lambda. Oh, sorry, lambda, right? PR is 3 lambda is half, so 3 over half minus 1. Half minus 2. And negative 2 times half is negative 1 plus 1. Negative 1 plus 1. So this would be half minus 3 over 2, 0. So this would just be half square plus negative 3 over 2 square root. Okay, so this would be, I hope I don't have any careless mistake, but we will see. 9 over 4, 5 root 5 over 2 units. Okay, so this is how you do this question here proficiently. Any question or comments, please do let us know. Keep practicing and I'll see you in the next question. Okay, yeah.